Chapter 2 Probability. In this video, let me explain this example. A personal director has two lists of applicants for jobs. List 1 contains the names of 5 women and 2 men, whereas list 2 contains the names of 2 women and 6 men. A name is randomly selected from list 1 and added to list 2. A name is then randomly selected from the augmented list 2. Given that the name selected is that of a man, what is the probability that a woman's name was originally selected from list 1? First, we need to define events. What are the events? If you read the last sentence, given that the name selected is that of a man, that means the final selection is the man, right? So we can define event A, man's name selected from list 2. Then the next one, you see what is the probability that a woman's name was originally selected from list 1. So we can define the event B, woman's name selected from list 1. Now write down the question in probability notation. What is the question? What is the probability that a woman's name was originally selected from list 1? That is the event B. So if we read only this sentence, we will write probability of B. But it is not the probability of B. You see the condition. Given that the name selected is that of a man, that is the event A. So event A is a condition here. Therefore, we need to find the probability B given A. Now let me write down the given information. We know list 1, 5 women and 2 men, and list 2, 2 women and 6 men. Now I am going to draw a tree diagram for this example. So first list 1, you know here how many total? Total 7 and 5 women and 2 men. So this represents the first list. Then go to the second list. But keep in mind what they are doing here. They pick one from the list 1 and add to the list 2. Now you have only 8 in list 2, but once you added 1, then it becomes total 9. Now you understand. Let me explain one here. Here you see first selection is a woman, right? Then go to the second one. We have only 2 women in the list 2, but with this selection it becomes 3. Therefore 3 over 9. But a man is a 6. Therefore 6, 9. But here first selection was a man. Therefore the 6 men become 7. But 2 women the same. So we need to find the probability B given A. Then we can write by the Bayes theorem. Probability B given A equal probability A given B times probability of B divided by the same part plus probability of A given B complement times probability of B complement. So what is the probability A given B? The B is the woman's name selected from list 1. From list 1, woman. Then we know it starts from here. And the list 2, A is the man's name selected from list 2. So then this is the conditional probability of A given B. Probability of A given B is this. That is 6 over 9, right? Yes, it is a 6 over 9. Then go to the probability of B. What is that? It is the woman's name selected from list 1. So woman's name selected from list 1 is this one, 5 over 7. So multiply by 5 over 7. Then we know the denominator we have the same. So we can write the same thing. Then go to the next one. Probability A given B complement. Then what is the probability of A given B complement? This one, right? So here B is woman's name selected from list 1. Then what is the B complement? B complement should be man's name selected from list 1. Then that should be here. That is the man's name selected from list 1, right? But what is the A? A is the man's name selected from list 2. Yes, you see here, this is the man's name selected from list 2. Then probability of A given B complement mean probability of man's name selected from list 2 given that man's name selected from list 1. It is 7 over 9. Therefore, the 7 over 9, then probability of B complement. B is the woman's name selected from list 1. Then the complement is man's name selected from list 1. That is what? Here you see that it is the selection of the first one. Therefore, 2 over 7. So we can multiply this and add them together, then divide it. So this is 15 over 22.